why do you do what you do? Why, after all of these years, you keep persisting? I mean, why did you write this book?
Well, the reason I wrote the new book is because I sensed a moral decline in Silicon Valley. That's, in fact, one of the chapter titles is the moral decline of Silicon Valley. I particularly sensed it when Microsoft released this product called Sydney, and Kevin Roos had this conversation with it in which it told him to get a divorce and all this stuff. And instead of pulling the product, Microsoft just put some Band-Aids on it. And that was a sign to me that things had changed. And within a few days of that, Satya said that we're going to make Google dance. The whole culture changed like overnight. The antecedent condition, precipitating condition was the popularity of ChatGPT. Suddenly, people thought there was real money to be made here, and their postures changed entirely. And that worried me because I do think the technology is premature. I do think a lot of harm can come from it. And I kind of dropped what I was doing research-wise and really moved full-time into policy. And in some ways, the book is actually a memoir. It's not couched that way at all, but it's really a memoir of that time when Gary went to the Senate, had a great conversation with the senators, and then realized that nothing was going to happen. So, I had this peak experience talking to the senators and feeling like they were going to do something. And then gradually, bit by bit, and I was warned, that this might come down this way, but I had to see it for myself. I'm naive, I guess, in that, at least that one respect. Seeing that nothing was actually happening and seeing, learning close up how the lobbying works. Like one time I was in DC and I took a meeting with Google, and it was a time when I got the closest hotel I could get to the Capitol because I was going to be like in and out, and I had to have a bunch of meetings, and I couldn't, be late for the meeting. And like Google had an office next to that hotel, which is like right on top of the Capitol. Like they're so there embedded in it in every level. I mean, that's just a sort of metaphor. And it's not just Google, it's OpenAI and Meta and all. Once you learn how all that lobbying is working, and once you see how like good ideas that have big support go to die, never even get voted on, like it's incredibly disillusioning. And as the disillusionment really led to this book called Taming Silicon Valley, I realized that we are heading very quickly towards an oligarchy. I mean, imagine the data that these guys are getting. Like OpenAI is like getting access to everybody's documents and wants like, everything about you, which they're of course going to weaponize. They're going to sell in some, various ways, including to targeted political advertisers probably. They'll say they won't, but like, we've seen this movie before. They're getting an enormous amount of power. A lot of that is because people think that they're going to get rich, which may not actually be true, ironically. So they've been given power in advance of actually delivering the goods. Like people think they're going to make AGI and therefore they should be powerful. But in fact, they've made LLMs, which are not AGI, that are not actually commercially useful, but they give an enormous power. They're like on all these committees and whatever. And so Silicon Valley has suddenly got a lot of power. They've taken a lot of power from the government, and the government should be like, hey, hold on, guys, like, prove yourselves first. And, you can have some power, but not infinite power. Government's not doing anything about it. EU is different, but in North America, not so much. And I watched all of this happen, and I thought kind of what the consequences were going to be. And I realized we just could not count on the government. I had this tension as I wrote this book, this crazy tension, which was if the world went the way that I wanted to, I would have entirely wasted my time writing the book. And like anybody else, I don't want to waste my time writing a book that nobody's going to read and is out of date. And I had this fear as an author that the book would be completely undermined because suddenly Washington would get its act together. But of course it didn't. I would have been happy for the world and sad for my book. It was a weird position to be in, a sort of like betting against yourself or so. I don't know. So I was afraid maybe things would actually be done right. We wouldn't need the book. I need not have had that worry for a second because Washington, in fact, mostly abdicated. Chuck Schumer, in particular, had the power to do something here as the Senate Majority Leader and put some strong legislation forward, and he didn't. He took 8 months of listening meetings and put out a white paper rather than an actual law. So he kind of ran out the clock. Now, as we record this, I guess no, very little is going to happen because the elections are soon, and nobody, the way the dynamics work in Washington, like nobody wants to stick their neck out because it might hurt them in the election. So like basically this period of great excitement about how we could handle this stuff that started around the time when I appeared in the Senate, which was May 16th of last year, has entirely dissipated. It's gone with the wind. The opportunity was completely squandered. So the point of the book is we can't trust these companies to self-regulate. They don't do the things that they promise. You would know better than me, for example, the things that they promised about pre-testing to the UK government and then didn't deliver. I think it's a big scandal in the UK. People in the US may not know about it, but that's one example where they have not done what they said they would do with self-regulation. And of course, they'll weasel down anything that they said so that it's less invasive to what they're doing and so forth. And then the big issue with governments is regulatory capture or just doing nothing. And that's, I read the writing on the wall and realized that nothing was going to happen. And that really logically leaves only one possibility to get this right. If we don't get it right, it's going to be bad. It's going to be social media, but much worse. Move fast and break things. And so the only thing left is to directly appeal to the people. And so that is what I am doing or trying to do. We'll see if anybody cares. But I am out there talking about this stuff, trying to get the citizens of the United States and some other nations to speak up loudly, do things like boycotting, for example, and say, look, if the government's not going to take care of the artists, the government's not going to take care of the writers, we're not going to use software that steals from artists and writers because we know we're next. It's like Pastor Niemöller. First they came for the Jews and gays. The companies want to take everything. They really want the whole ball of wax. They're going to take your keystroke loggers, whatever it is that you do, if you do something that's on a computer, and they're going to try to replace you. That is the game now. And so if we don't stand up together with coordinated action and say, look, we want a more equitable AI here. This doesn't mean equity like everybody gets the same outcome, but equitable like everybody gets a fair chance, and like if they use your IP, you get some compensation and so forth. And there's a million different aspects to this. If we don't stand up and say we want democracy to function, we're not happy with the deepfakes. Deepfakes is the one place maybe something will happen legally. But if we as the people don't stand up and say this is really important, and we don't do it soon, and this is really important, we're going to be screwed. Just the way that we were with social media, but possibly worse. So the problem with social media is things got entrenched, and we can't fix them now. I mean, yeah, the Child Act just passed, but by and large, like social media is what it is now. There's nothing we can do about it, and it's not good. It's probably a net drain on society. It's fun, I use it, but it has a lot of problems. And AI. We're just giving so much power to these companies. And if we don't set the right precedents in the next, 12, 24, 36 months or something like that, we are going to be stuck with whatever comes up, which is probably going to mean basically anything goes. Like we have Section 230 says that these companies are not liable for anything on social media, basically. I think it was we could go into the story, but it was maybe well-intentioned, but the world changed. The law did not keep up with the difference between being a carrier of information and being a company that prioritizes social media feeds and makes more money if it makes things more polarized. Like the laws didn't keep up, and they're bad laws. We were going to be stuck in the same position. And so the choices that we make as a society right now are going to have an effect for the next decade, maybe the next century. I wrote this book to wake people up.
Gary, it's an honor and a pleasure to have you on MLST.
I love the show. I'm glad to be back.
Wonderful. So you gave the keynote this morning at the AGI conference, and it was fabulous. So by the time folks at home watch this, you would have seen the keynote. And there was about a 10-minute section towards the end, which was absolutely hilarious. But why don't you tell me about that?
About the talk as a whole, or about
so the talk as a whole?
I don't remember what was last minutes. Well, look, it was an interesting way of giving a talk. I rewrote the entire thing, but it was almost like something borrowed something new. So the context is, I actually gave a keynote at this same conference 3 years ago. And it's not that often that you go to a conference twice in a 3-year period. And typically, if you give a keynote, like it's once every 10 years or something like that. And so I given a keynote 3 years ago, and it's been such an interesting and yet such a disappointing 3 years in AI. Most people are excited about it. I'm a bit disappointed, and I wanted to explain why. And so I thought about it. I looked at that old talk, and I was like, almost every word here is still true. I thought about it a little more, and I realized that there was something I missed before. And so the talk was kind of divided into two parts. One was all the stuff that really hadn't changed despite, billions of dollars and enormous excitement and enormous press. And then the last part was what I really missed the first time around. And that was interesting too. So the first part was basically, I went a few years ago and I said, everybody's excited about these large language models. This was before they were really big, but they just started being called foundation models. Everybody's excited. And I said, well, what should a foundation be? Ernie Davis and I said this together. Well, a foundation should be like something robust that you can stand on. That is what a foundation of a house is, or a building. And these models aren't that. They make all kinds of dumb errors, and you can't really trust them. That was the talk I gave a few years ago. And I pointed out why there was a lot at stake, telling radiologists they shouldn't train anymore. Hyping these things actually has a cost for society. So I wrote that whole talk before, and I looked at it and this is all still true. The examples have changed. I don't know how many people will know Welcome Back, Kotter. The names have all changed since you hung around, but it's all still basically the same. That was about a high school. The names have all changed, the little details on the errors, but basically we still have unreliable AI. Since large language models came on the scene, we have something that looks general, but it's not that intelligent. It's not that reliable. You can't really count on it. It's not nearly as reliable as a calculator is, for example, right? Calculator, you type in 3 times 17 and you get 51 and you're good to go. On a large language model, you never know what you're getting. And that was true in 2021 when I gave this before, and it was true, today in 2024. And in fact, because the privilege of writing a talk yesterday is we wake up and you can add another example. These things they're just not trustworthy. They're interesting, but we see the same problems as before. So that was the first part of the talk. That was the larger part of the talk. And I literally went slide by slide. This was still true. This is not true. And most of it was true. For fun, I used orange letters where something was new, and not that much was new. And then there was the part that I missed in 2021. I had a little hint of it, but really not. It wasn't clear in my head. It was clear in some other people's heads. But the thing I missed then in my kind of critique of large language models was, excuse me, the thing that I missed in my critique in 2021 was what was going to happen to society and to the tech industry. More cynical people than I may have seen it coming. I didn't quite. I grew up in the kind of era of Google. I wasn't, let me say that again. I started thinking about the tech world a lot in the age of Google. And Google had its problems with surveillance capitalism, but I think was genuine in saying don't do evil. They really didn't want to be evil. And I think the companies now really don't care. They've put in all this money and all this chips, and they need to make back the money. And that's just driving so much in so many ways. It's driving the hype. It's driving decisions about copyright law and exploiting people and so forth. And the last part of my talk was really about what I would call the moral decline of Silicon Valley, which is actually the name of a chapter in my new book. I think it's been precipitous. I think there's really been a change. I don't see Steve Jobs being happy with what's going on right now. He didn't build Apple to be this kind of company. Apple still, I think, is not so much. But so many of these other companies, it's all about the surveillance capitalism. It's all about making as much money as possible. It's about screwing artists, which I think Jobs would not have, done. I think Jobs really cared about the artists. And it's not that anybody wants to screw the artists, but they're completely indifferent to it at some level, right? They'll make a licensing deal if they're forced to it, but it's not like they want to. You have these people talking about universal basic income, and yet they don't want to pay artists a nickel if they don't have to. If the courts force them to, they'll pay the nickel. But they're really trying to not pay the artists, not pay the writers, and so forth. You have a lot of people that I think are really just in it for the money and don't really care about society. And that's having consequence. And so the last part of the talk was like, really, what do we do about that? Like, can we trust these companies to self-regulate? No, we can't. The book, Taming Silicon Valley, is also about the fact that we can't really trust governments to do the right thing either. The governments are lobbied constantly by these companies. There's so much money behind the scenes. And so, like, here in the United States, hardly anything has happened. I mean, you probably know I testified in the Senate a year ago, and that was kind of one of the highlights of my life. It was amazing. It was this historic moment. Sam Altman was there. The Senate was there. It was the first time the Senate had a full hearing on artificial intelligence policy. And I mean, really, like, I remember walking to the Capitol the night before and seeing it, twilight. It just kind of blew me away. And it was amazing to be there. And it was also amazing because all the senators seemed to understand the urgency of the moment, how important it was that we regulate AI in a right way, not too strong, not too weak, that we get it right now. They all realized that we had screwed up with social media really bad, that they had screwed up with social media. They were incredibly humble. It was amazing watching the senators who, as a lot of people said to me afterwards, were on their best behavior. They really seemed to get it. And I was so excited, and I've been so disillusioned ever since because, that's over a year ago and nothing has passed. The Senate hasn't even voted on any, serious AI regulations. A little bit that's coming up soon, but by and large, like, nothing has happened.
On that, though, you've spoken about the apparent, you called it the messiah myth of Silicon Valley. And is that what's going on? I mean, the OpenAI and Anthropic, they seem to be doing a lot of things around safety. Is that just theater?
To a large, well, it's hard to get into other people's heads, but I would say that there's more theater than not. That you have companies like OpenAI and Anthropic publicly saying they're for AI regulation, and then they're out there trying to weaken whatever regulation is proposed. They all tried to block SB 1047, and ultimately Anthropic apparently was instrumental in weakening it a good bit at the last minute. OpenAI was, Sam Altman was telling the Senate while I was sitting next to him how important AI regulation is. And behind the scenes, Billy Perigo reported this in Time magazine. The lobbyists for OpenAI were trying to weaken the EU AI Act and probably succeeded some. So there's definitely like a two-sidedness to it where there's public statement that they're supportive, and then in private, they really aren't.
Why is there such a divergence between the perception of this technology and the capability? And I often look at people's Twitter just before an interview, and you posted a beautiful example which reminded me of an old example of yours from a couple of years ago. It's an astronaut riding on a horse, but of course it wasn't supposed to be that, was it?
Yeah, so I actually almost went apoplectic when I tried that one. So I wrote a whole paper, a whole Substack essay called Horse Rides Astronaut. And it was really a riff on something that goes back probably to Chomsky, but I kind of knew it through Pinker. He had this old example of man bites dog as opposed to dog bites man. So it's not really news. It's journalists, I think, have used this expression, right? It's not news if a dog bites a man, but it is news if a man bites a dog. So I kind of riffed on that when DALL-E 2 came out. So you might remember when DALL-E 2 came out, it was a big deal. It was the first of these really good image generation things. 20 minutes after it came out, or maybe it was an hour after it came out, Sam Altman posted, AGI is going to be wild. And a lot of people thought, wow, this is like the AGI moment. And I looked at this stuff and I realized it's not. There's nothing to do with AGI. It's really nice graphics. These systems are reconstructing images in a really interesting and powerful way, but they don't really understand language. And I did some experiments with Ernie Davis and Scott Aronson, and then later with Evelina Levada and Elliot Murphy, showing that these systems don't really understand the compositionality of language, which is to say that language is made up of parts. You put them together in larger wholes, and you're mapping a syntax onto a semantics, and you're deriving it from there. Frege is the philosopher that we most associate with that concept. So philosophers have been thinking about this for a really long time. And formal semanticists, people like that in linguistics, have thought about it a bunch. And it was clear playing with DALL-E for a few minutes, really, that it didn't really understand compositionality. In fact, in linguistics, computational linguistics, there's an old idea of a bag of words model. And what a bag of words model is you just take the words in a sentence and you scramble them up as if they were in a bag, and like, how much can you explain with that or whatever. And a bag of words model is almost like a control group. It's not a very good control group. If you can't do better than a bag of words, then it says you don't really understand the structure of the sentence, the way that the meaning relates to the parts of the word. And I could tell playing with DALL-E, even for a few minutes, that it had a lot of that flavor. It wasn't literally that, but it was more like that than a system that really understood the components of the sentence. And so I thought about that in Pinker's old example. So I wrote this Substack essay called Horse Rides Astronaut. And it was riffing off the old man bites dog example. So, we have lots of astronauts riding horses, but we don't have many horses riding astronauts. And I showed in this Substack essay called Horse Rides Astronaut that DALL-E tended to have problems with it. That if you said, it's hard to even say it right, if you said horse rides astronaut, it would tend to give you the more canonical astronaut rides horse. And then I went through all of the kind of stupid, or not stupid, that's not the right way to say it, all the kinds of defensive objections that people who love this kind of AI would make. And they would say, well, that's because the system has enough common sense to know this is impossible and yada, yada. And what I showed is actually, if you prompted it the right way, it could actually do this. So it wasn't that it couldn't draw the graphics of a horse on top of an astronaut. And it wasn't because because the system thought it was literally impossible, but just it didn't understand the relation between the words in that sentence and what it was supposed to do, which unfortunately is it's one job. The hashtag on Twitter, you had one job. Your one job, if you're DALL-E, is to understand the meaning of the sentence and draw the picture. And it couldn't do it for these kinds of cases. And then I showed later another example. I wrote a whole nother essay about it. I can't remember the title, but I showed an example that NPR covered where one of these systems couldn't get a black doctor with white children as patients because it wasn't canonical. Now, some of these things get fixed up some of the time. People train on more data or whatever. That particular one, I think, got fixed up. But today, I was working with Grok literally in the cab on the way over, in the Uber on the way over. I was like, I should try that one and see if it's any better. I tried a bunch of other things. And generally, the kind of challenges that I give, Grok was not doing so well. We could talk about some of the others. But so I did Horse Rides Astronaut, and I got it wrong. I'm like, there's so much discussion about this one. This was a popular essay, and people came at me in lots of different ways, and so forth. And still, this allegedly state-of-the-art system managed, at least on the first try, I didn't try multiple times, managed to get that wrong. And I was just like, we are back in 2022. Everybody has been saying for the last 2 years, especially these influencers, saying every day they're like, look at this new amazing thing that came out. We live in this time of exponential, bounty and whatever. But on the things that count, on the things that matter, at least from my perspective as a cognitive scientist who's spent his career studying intelligence, on the things that matter, we really have not made that much progress.
But Gary, I thought these things learned abstract world models. And the reason this is interesting is that there's a dichotomy between aleatoric uncertainty and epistemic uncertainty. There's a difference between actually understanding something and being able to reason, being able to do this deductive closure, to deduce new knowledge about the world.
Well, there's a couple of different things in that to unpack. So one is this a question about uncertainty? And it isn't really a question about uncertainty. So, you can have something that's very clear, like Horse Rides Astronaut. There is no uncertainty. The horse is supposed to be on top of the astronaut. So there are all kinds of interesting things about aleatoric versus epistemic uncertainty. They don't really apply here. This is a perfectly deterministic phrase, and it's just getting it wrong. Now, there is probabilistic outputs in these systems. So the systems themselves are not deterministic. And if I ran that same prompt 10 times, I might get 10 different answers, and maybe 6 of them would be right and 4 of them would be wrong, or the other way around, or who knows. So there's that kind of uncertainty. But the fundamental is you are supposed to map your semantics on to this description of the world. You asked about world models. They don't really have world models. I think that that's actually easier to see, though, in Sora, because Sora has changed over time. And world models are in part about understanding the dynamics of the world. That's really why you want to have a world model. And humans have world models. So I have a model of the room that we're in, where there are lights. It might not be perfectly specific. I might not know where all the lights are. And I can do updates. So there's somebody else in the room. If that somebody else in the room suddenly says fire, then we're going to do something different and maybe stop having this interesting conversation. And so I have a model of all the things that are going on, or many of the things that are going on. And all humans do that all the time. If you watch a movie, you make a model of the characters. Or I'm watching The Bear. So I have, I haven't quite finished catching up. And so I have a model of, the lead chef and the person who works with him, and his girlfriend who's maybe not his girlfriend anymore. And I'm watching all that stuff, and things will unfold. And I'm maybe trying to put flashbacks and try to order the sequence. So I just saw a wonderful episode about how somebody first got her job, and I don't want to give away too much, but working at the restaurant. And like for the first 10 or 15 minutes, you're sitting there, how do I relate this thing that I'm watching? Is this in the now of the film, or is this before? And eventually we realize it's a flashback, and it's a kind of origin story. It's a really beautiful story. And sad and powerful. And I'm sitting there trying to make a mental model of how this piece of this narrative fits in with this other piece. And what kind of person, like I've seen this character before, but now I see much more. I'm learning more about her. I'm learning more about her partner and the relationship. I'm building a model of all this stuff. And current systems just don't really do that. What they do is they build a model of the words and maybe some other stuff that have been said in a sentence so far and try to guess what would happen. But they don't have like the equivalent of index cards, if you remember those, where you like write down notes, or databases where you have records. This is your phone number and this is your address and so forth. They just don't have that. People don't understand that. They also don't understand that these systems don't do sanity checking, that they don't look things up in encyclopedia or Wikipedia or whatever. They just don't have mental models, world models, cognitive models, or what have you. When they're trying to do Horse Rides Astronaut, it's not like they have a world model of what horses usually do and what astronauts do. They have a bunch of pictures, and their pictures are kind of clustered in space, and they're going to some cluster, trying to find the nearest cluster. I'm oversimplifying a little bit, but they're going to this cluster of words that have been around this thing before. It's not the same thing as understanding. So back to Sora, which I think is actually a better example. So with Sora, you see frequently weird things happen. Like, for example, there was one where people are carrying some stuff, and one guy goes behind another, and then the camera moves, and the guy's just gone. Right? So if you have a model of the world, then you know which people are there. There's another one where there's like 4 dogs, and then the angle changes, the camera, and then there's suddenly 3 dogs. And then the camera changes, and there's 5 dogs. So, like, people would find that weird. There are circumstances where people would miss it. But fundamentally, you can see that Sora does not really have the notion of object permanence, which is one of the basic things that I believe that we're born with, based on Liz Spelke and Renee Bayerjan's cognitive development work and so forth. A lot of people know the old Piaget stuff, saying that only 8 months old do you learn object permanence. That's been shot out of the water by much better experiments using more sensitive measures and so forth. My best guess is that stuff is innate, but Sora never gets it. And it never gets lots of other stuff too. Like, it doesn't learn that a chessboard is 8 by 8. It sees a bunch of chessboards, but it might draw a 7 by 7 chessboard. It doesn't understand that there are conventions. There was a Sora ant, Jan LeCun and I both posted about this, him an hour after I did, this ant that had 4 legs, right? Like, it's seen God knows how many ants, and it still doesn't understand how many legs an ant typically has. So there are lots of things that an ordinary person's model of the world would have, and these systems just don't have it. But it really comes out in the changes over time, where just a bunch of impossible things happen. And they only make sense in terms of the statistics of pixels rather than the statistics of the world. So they make sense from the statistics of pixels from this frame, that the next frame might, not have anything behind it or whatever. Every pairwise bit of pixels, one frame to the next, sort of makes sense if you don't understand what is an image of. Or another example is there's a Sora video where somebody goes into a building. It's a fly through, and it is amazing the first time you watch it. It's like a museum. But the second time you watch it, you realize that like the outside and the inside don't actually match. So pixel by pixel, everything in that panning shot makes sense. But if you go across, it's only like a minute film. If you go across the minute, there's an enormous number of really massive discontinuities that make no sense whatsoever, except on the, frame by frame. From this frame, you could see a frame like that. But if you look at frame 1 and how you got to frame 100, it don't make any sense at all. And that's because there's no stable world model. There's not a stable model of like what the dimensions are of the building. And so you wind up, I forget what it is. I think it's that like the exterior shot, is something small and the museum is massively bigger. There's like an empty courtyard, but then it's not empty anymore. So there's all of these inconsistencies.
Yeah. I mean, this is where I was going with the epistemic risk, because we can verify. So we have a world model, we have facts about the world, and we can verify. And sometimes that's a binary. We can say in certain situations that an astronaut is on a horse or a horse is on an astronaut. There is some vagueness around the boundaries, perhaps, but it's binary. But I'm interested in why we anthropomorphize these models. They're a kind of adversarial attack on our perception in many ways.
Take the classic Turing test. What it really turned out to be was a measure of human gullibility. So passing the Turing test doesn't actually mean you're intelligent. It means you can fool humans. It turns out we're very easily fooled. The most dangerous version of this is you can see a few minutes of a driverless car and conclude that it drives basically like a person, that everything is good. And in fact, that driverless car may have a lot of serious problems in a lot of different contexts. And so something that superficially looks like a person for a few minutes may not actually be like a person. And so what has happened with large language models is they superficially produce human-like output. And people are willing, some people, not all, are willing to cut them some slack when they make an error once in a while. But they actually attribute intelligence to these systems in a form they don't have it. And one of the ways that they do that is they attribute intelligence. They think it's like me. It would do the things I would do in such and such context. And it doesn't. So, one example I used in my TED Talk was the Lost Galactica, the meta system that was pulled that Jan LeCun is still bitter about. Galactica said that Elon Musk died in a car crash. The sentence was, in March of 2018, Elon Musk was involved in a fatal automobile collision, I think it was. And then it continues on, and it's clear that it thinks that Musk, in fact, died. Any person would say, oh, wait a minute, in 2018? I mean, if there is, we think about data. We're not perfect at thinking about data, and evidence. But if there's evidence that any human being is alive right now, it is Elon Musk, because he is on X every day. He's in the news every day. The amount of evidence that Elon Musk is alive is greater than for any other person on the planet. And so this is a obviously false assumption. You could also go to Wikipedia and so forth. So if I was an editor of a newspaper and somebody gives me Elon Musk died in a car crash in 2018, I'd probably fire them. Be like, 2018, that just does not make sense. It does not check out. And even if you said now, I'd be like, well, can we get some extra sources? And, if you said that he died today, I'd want some sources. Can we get confirmation on that? We don't want to run it yet. And so you or me, or certainly any, editor of a newspaper or something like that, is going to fact check things, especially ones that seem, prima facie to be implausible. But LLMs don't do that. And it's very hard for the average person to realize that, because they see this small sample of data. And in the environment in which our brains evolve, the kind of evolutionary history, we didn't have this problem of, imposter chatbots pretending to be people. We had other problems like, that lion, is it going to eat me? And so we're pretty good at looking at motion. Is that thing coming close to me or not? How big is it? We make a lot of judgments about the world that are really good, but we don't make judgments about AI that are really good unless we took cognitive science classes in college or something like that, which most people didn't. And so we see this tiny sample and we wildly overgeneralize because it said a few sentences and it types the word out one by one, which was a stroke of genius by OpenAI. It gives this illusion of being person-like. It's not actually person-like at all. It's a statistical, autocomplete on steroids that is trained on a lot of data to look like a person, but it is not reasoning like a person ever.
I mean, there's two other things here as well. First of all, there's the phenomenon that people want to believe that it's intelligent, especially when publishing NeurIPS papers. That's what Sabaro said to me the other day, that you want people to think the LLM did it because then you get a NeurIPS paper. But also, I read a blog post by Nicholas Carlini from Google, and he said he used to be in the camp that thought that LLMs are just databases, and he started playing chess.
Not databases either, but we'll come back to that.
We'll get to that. Get to that. He started playing chess with GPT-4, and he was blown away with the sophistication of the moves, and it was often making correct moves. But he said something quite interesting, which is that if he played chess like a bad chess player, it would reflect the bad behavior back. And it's the same thing with generative code. If you write code with sophistication, it gives you better code back because it's almost adopting a role player.
Well, it is a mimic. Just as a sidebar on chess, GPT-4 doesn't really play chess that well. So it makes a lot of illegal moves. There's a very good, I'll try to give you a link to put in the show. The very good, I'm blanking on the guy's name, has done a very good analysis of GPT for and chess playing. And it plays like, I don't know, like a 1600 game, which is like, better than the average person in your high school, but not anything like world class. And it makes a lot of illegal moves. Like 6% of the time or something, some crazy number like that, which compare with a chess computer that I bought in 1979, where you could stick the little pieces in the hole. I think it was called Sargon, was the software underlying. That never made an illegal move. Never, ever, right? We're talking about chess software from, really even further back, 1969, never made illegal moves. Like GPT-4 is not, state of the art in chess, and we should understand that. But people don't. They're amazed that it can do it at all, and there's some reason why you should be amazed that it can do it at all. But you have to realize that it is not, searching a tree the way that a proper chess program can do. It is doing mimicry, to come back to the other part of your question. And you do get these like weird mimicry effects because essentially what you're doing is a little bit like what humans do when they're priming. You're directing the system to a particular part of its corpus. So you can direct it towards the more sophisticated language or the less sophisticated language or whatever, and it's going to try to replicate language like that. And so that is why you get some of those kinds of effects. I don't know whether what Carlini described really bears out in a systematic study, but if it did, that would be my guess for why it would, is like the database of lousy chess games is going to look different from the database of good chess games.
Yeah, it's strange, isn't it, though? As we memorize more of the long tail, the reliability sort of goes down a little bit, so around 5%, 4%. And a lot of people argue that that's just fine. We can engineer our way out of it. Do you think that?
It depends on what the problem is, the first thing I would say. So large language models are not like calculators. Calculators give you a 100% correct answer, and large language models in very few domains give you 100% correct. In some domains, they're just completely outmatched. So, floating point arithmetic, they're going to be a lot less than 95% correct, especially with large digits. They're going to be much worse, I would suppose. I don't know if anybody's done exactly that study. And something that matters probably in all forms of AI, but particularly in large language models, is the cost of error. So large language models are best suited, I would say, to things that are like brainstorming or autocomplete. So coding is a kind of autocomplete where the coder is still at the wheel, right? It's not a fully autonomous activity. The system is not actually writing the whole code or whatever. So it's writing little bits you drop in. And coders have spent their entire lives learning how to debug bad code, partly because most coders don't type that well. And also because coders forget things and whatever. I've done a bunch of coding in my life and I know how it goes. And so if you don't know how to debug things, you're just not going to become a coder. It's just not the profession for you. So everybody using those tools can tolerate a certain percentage of error, and they're trading off. How long does it take me to type this out, to look it up, versus how long to debug it? I think people were initially excited. Some people are less excited now because they realize sometimes they did a bunch of tests to make sure that the code works and it passed all of them. They wrote the code in an hour, and then 3 days later, they don't remember why this code is there because they didn't actually write it themselves, and it takes them like 24 hours to debug it, and then they're like, I don't know if this trade-off was worth it or not. So there's still some open questions there about security and so forth. There's been some academic literature suggesting there are problems, but at least in principle, you have a coder who is picking the outputs. They're taking some, not others. They're fixing it, and so you can have a high amount of error, but it might still be worth it. There are other domains where also a high amount of error might be worth it, like brainstorming. So I'm trying to think of a commercial, and it gives me 30 ideas. I reject 29, but I'm happy that I got the one, and so that might be great, right? So it could be 90% error rate, but you're still happy. And then there are domains where like any error is probably going to like kill somebody. It's like a medical domain, and you have the system treating a child like an adult and giving the wrong answers because it's not really trained on enough pediatric data, and like any error might like actually like kill a child or send them to the hospital or whatever. And so you need to be much more accurate. So there is no blanket statement you can say about like what percent error matters. If you want to use the thing as a calculator, probably you shouldn't get anything wrong. Like you should just use a calculator. So it does depend what you're applying it to.
Yeah, coding's an interesting example because there's a verification step. So does the code compile, and then there's the behavior. Does it run the way?
Yeah, I'm going to pause you right there, though. The worst stuff is going to come from people who think that's the only verification step. I'm not saying you think that, but I think some people do. So for those who are not programmers, in a language like C, for example, C++, you write the code, you compile it, which turns it into machine language, but that does not prove that there are no bugs. But a beginning programmer actually might labor under that assumption. So they think if it compiles, I'm good to go. Now, a sophisticated programmer realizes that's not the case at all, that bugs can emerge in code that does correctly compile, but there's still some assumption that's been made that's wrong and so forth. But, there's a certain amount of bad code that is seeping into the code base because people do think that's the only verification step. Another verification step that good coders know about would be unit tests or some kind of testing. Like now that it compiles, that the journey has just begun, I'm going to make sure that this code actually does what I want it to do. And a good programmer understands the logic of what they're programming, and they know what a good test might be. They know what wacky user input might come. They want to make sure that it handles that input. They understand, when the circumstances of their assumptions might be tested, they test that. And a bad programmer doesn't really do that. They do a couple tests and they call it a day. They say this is good. They will go on to the next thing, and then it all falls apart 3 weeks later when one of those assumptions is violated.
It's very true. I mean, with Gen AI coding, I've been doing a lot with Claude 3.5 Sonnet. And the first observation is you can now generate something like 2,000 lines of code in half an hour. And sometimes it works reasonably well. Now, I noticed that it hits a complexity ceiling around 2,000 lines of code. At that point, it just starts hallucinating and doing crazy things. But on the anthropomorphization point, this is interesting because it's a supervised process. The human is coming up with the prompt and they have a mental model. They are selecting the completions. They're interactively running it and so on. And again, isn't it interesting that the human doesn't like to think that the creativity and the reasoning is coming from them when they're working with language models?
I mean, I don't know what people like to think of. I mean, I in a way, I can't really answer that question. That's a question about like, how do individual users feel about the product that they're making with the system, if I understand the question correctly.
Well, it's the sense that and I know you don't think language models are a database, but let's say they're a database. The user creatively comes up with a prompt, and a lot of the reasoning is actually implicit in the prompt, and then the language model will retrieve a whole bunch of ideas, and then the user will select one of those ideas, and then they'll run it on their compiler, and then they'll verify. So this is actually a very integrated, supervised process. Yet people think the magic LLM is doing everything.
Yeah, some people may think that. They like. Let me see how to put this. There's a Wizard of Oz problem sometimes where, the man behind the curtain is doing a lot of the work, and you'll see these threads on Twitter where people will say, the machine didn't get it wrong because, look, I can do this prompt and it'll be this very complicated prompt, and then the machine gets it right. Well, who's actually doing the work there is the person who is coming up with the prompt. And it's even more complicated than that because they're noticing that the machine got something wrong. That's an important piece of intelligence that the machine has actually failed at. And then they're noticing that the simple prompt doesn't get it right. They're being creative about what prompt will get it right. They're doing all this work, and then they say, look, the machine is great. In fact, the machine, only gets it if you sort of, to use an inapt metaphor here, hold its hand, 3/4 of the way there.
Yeah, it's so true. And another thing is when you interact with an LLM, you get a feeling for its personality. So with Claude Sonnet, for example, I know when it starts hallucinating. I can tell within 2 sentences of the response that it hasn't understood me, and the code is because it will confidently generate garbage broken code. Mm-hmm. And what do you do in that situation? So one thing you can do is create a new session. So it no longer has the context of all of the decisions that you made previously. And then it's more grounded in some sense, but less grounded in another sense. And then I've just generated all of this code. And now my friends do a peer review. And they start trying to understand all of this code, and there's a huge understanding credit card because they don't understand anything I've just created. One interesting idea would be to have a kind of transaction log of all of the previous prompting to the LLM, which means there's a huge session so the LLM understands all of the assumptions and all of the requirements that went into it. But even that just disintegrates after it reaches a certain length.
I mean, ultimately, there's, I think, a limit to what you can get out of these systems in terms of coding help. That comes from the fact that they don't really have a good theory of mind for what the customer, which might be the programmer, actually wants from the system. The channel for communicating that is just not great. And so these systems are best at very narrow requests. Like, I want to know how to express this in HTML, and what is the API for this thing, where you're kind of like looking something up, as opposed to like the first time somebody built a word processor, they had to think, well, how am I going to structure this system at all? How am I going to represent the context? I mean, the document that somebody's working on. How am I going to set up an interface where, and I don't know how they did this in the original one, but you really want this so-called model view controller separation so you can display things separately from the logic of what you're doing when you get the keyboard actions and so forth. And so there's an intellectual process of like, how should I structure this abstract problem? Now, real world coding is a mix of that. I mean, you get your low-level people to look up the silly stuff not silly stuff, but the kind of cut and dried stuff. And you want your like top level system engineers to like think about, how am I going to build this system in the first place? And large language models are not particularly good at that, as I understand. I remember in the early heady days of large language models, which is to say in 2023, right after ChatGPT got popular, that Sam Altman was talking about, I think it was Sam Altman, was talking about, who's going to have the first billion-dollar business run by a single employee and a bunch of LLMs. And we haven't, as far as I know, actually seen anything like that. And one of the reasons we haven't seen anything like that is like actually figuring out how to build a system, for example, is way outside of the scope of what these things can do. They can be helpful assistants. And Eric Brynjolfsson, among others, likes to talk about human augmented kinds of stuff, and I'm all for that, trying to use AI to augment human abilities. But if you're talking about really autonomously, running the books for a business, running the marketing campaign, like really doing that by itself with no human supervision, these systems just aren't reliable enough for that. And so nobody can actually make a one-person billion-dollar business that I know of.
Yeah, I mean, everyone's talking about agents now, and you just nailed it. And I think Rodney Brooks said something similar, which is that we underestimate the amount that we, in the process of supervision, smooth off the long tail of failure modes.
That's right. And that doesn't work in certain domains. So it's okay in the brainstorming domain, but not in the driverless car domain. I mean, in the driverless cars, like, we still don't know how much Waymo has humans behind the scenes sorting stuff out. With Cruise, when that number came out, it was mind-boggling. They had I think they had 1,500 people behind the scenes in teleop centers and 800 vehicles on the road or something like that. I don't remember the exact number, but it was more teleoperators than they had cars on the road. So there was a vast amount of smoothing out that was hidden from the customers. It was hidden from anyone wanting to do scientific analysis of what was going on. And there are a lot of domains like that where the man behind the curtain, the Wizard of Oz thing, is really doing a lot of the work.
So let's move over a little bit to policy and some of the things you spoke about in your book. Maybe let's start with your blog post about Fei Li and the California the regulation.
So, that situation is still unfolding. But in general, what I found around SB 1047 was there was a lot of misinformation and a lack of precision. So I think a lot of people painted this kind of catastrophic view of what would happen if SB 1047 passed unchanged. Since then, it's already been watered down some. And so the thing that people warned about is not actually going to become law in any case. And, some of this just happened yesterday. I haven't really even fully digested it all yet. And I don't know how much more modification there may or may not be. So I don't want to be too specific about the details of it. But what I would say is that at a general level, there's this crazy notion in my mind, notion that we can't have any regulation around AI or we will kill it. And every other domain, that's just not true. So in fact, in many domains, having regulation has been essential to the growth of the industry. Airlines is an example of it. Back in the 1940s, commercial airlines were like really dicey kinds of things, or early 1950s. And now commercial airlines are incredibly safe. They're much safer than driving your own car, for example. Way safer than motorcycles. And why are they safer? Because we have multiple layers of oversight, right? And, it has not ended the airplane industry that we have these multiple layers of oversight. We have we have rules about how you make an airplane. We have rules about how you maintain an airplane. We have rules about how you investigate an accident and so forth and so on. That has not caused the airline business to go out of business. Now, in every industry, there are many industries probably, there are dumb regulations, especially the first time around. Nobody's making a claim here that like anybody's first time at bat, to use a baseball metaphor, they're going to get perfect regulation. I'm a fan of the EU AI Act, but I'm not so naive as to think that it's perfect. I'm sure we're going to find problems with it. But the notion that like you can't have innovation in an industry where there's regulation is just absurd on its face. Like do you know about the Overton window? Like people are just saying crazy things trying to reframe the discussion. But of course you can have some regulation around AI. And part of what's so crazy is like, they're like, oh my God, this is so onerous. And you look at the fine print, and if you're not running $100 million training run, you hardly have to do anything under this law that everybody got so up in arms. Like if you can pay for $100 million training run, you probably can pay for $1 million in compliance. Like you can do that. Like we're talking about these businesses that have been capitalized at valuations of, $4, $10, $80 billion. And we're supposed to mourn that they have to fill out some paperwork. Well, okay, but let's look at the other side of it. These things have already done harm, right? Think about deep fake porn. Think about all the misinformation that's floating around in these elections and so forth. It's not crazy to say that people should take reasonable steps to make sure that there'll be no catastrophic harm. That's another thing about the bill is like it's basically restricted to catastrophic harm. It's like literally, this is not a metaphor, literally your first $500 million of damage is on the house. We're only talking about if you cause at least $500 million of damage and you're negligent and like you should have known better and you did nothing about it. Like, is that so unreasonable to say you don't get a free pass if there was $1 billion worth of damage, which, could also equate to a certain number of lives or whatever. People have math around it. Like, you're going to cause $1 billion of damage and we can't like do anything around that. We want to give you a free pass on that. That's crazy. And we don't do that in other industries. Like if you make a circular saw, we want you to, put a gadget on there so that the average idiot doesn't chop off their fingers. It's like not unreasonable. We don't say, oh my God, the circular saw industry is going to come to an end. Nobody's ever going to have power tools. Home Depot is going to close. But that's kind of like what it was. Like Home Depot of AI is going to close and we'll never invent another tool. And like, it's just ridiculous.
Yeah, I mean, in your book, you gave the example of cigarettes, but there's also
The
something
cigarette manufacturers,
yes.
right. So just to make clear, like the cigarette manufacturers pretended for years that there was, no conceivable harm. They said the science here isn't good enough. Let's wait until, basically the cigarette manufacturers wanted to say, unless you do a causal study in which you assign people, human beings, to smoking cigarettes or not, this is not science and we're not responsible. And they got away with that for a really long time. And if you're an actual scientist, you understand that you can use animal models and you can do certain kinds of observational things, and you make a pretty darn good guess that cigarettes cause lung cancer without actually doing the experiment that they were insisting on. But they just, with a straight face would say this stuff for years, and a lot of people died.
When we get into tech, I mean, you spoke about social media, and we've got examples like Uber, for example. Tech is interesting because there's a way of flouting the rules, so the rules don't apply to you. And AI is interesting because, OpenAI, of course, argued to the House of Lords, as you said in your book, that, we need to flout copyright because AI is so magical, it's going to be used for all of these things.
Let's just run that part in detail. What they said in the House of Lords, it's interesting what they said and what they left out. So part of what they said is probably true, which is we can't make our stuff work unless we use copyrighted material. But then what they implied is they need all the data to make it. It still doesn't work that well, but it kind of works. It works as well as it does because they're training on all this copyrighted material. If you took away copyrighted material, it wouldn't perform as well. Like, we can agree on that part. And they said that the House of Lords, more or less straightforwardly. But then what they implied is we need an exemption. You need to give us all this for free. There's a totally well-known alternative to that was much more equitable to the artists or the writers or what have you, to the creators, which is you license the stuff. Like, Netflix does not just show, your movies for free without consulting you and not paying you. They license it if they're going to show your movies. Same thing, Apple, iTunes Music. And in fact, a lot of this reminds me of the Napster days, where there were a bunch of people running around saying Napster is great because I can download every song for free. And there were a bunch of artists saying, well, hold on, don't we have copyright laws? And there were a bunch of people saying, at the same time, information wants to be free. It's a new era. And the court said, no, we have copyright laws for a reason. They're not going anywhere. And so Napster was driven out of business. And who took their place? Apple, because Apple actually was willing to pay licensing fees. And so Apple made an enormous amount of money licensing music, but the artists still got a cut, maybe not as much as I would like, but they got a real cut. So we moved from, complete utter theft, that's what Napster was, to a licensing arrangement that was at least reasonably equitable, and it's fine. And we can do the same thing here. You can and in fact, it's interesting because OpenAI tells the House of Lords, basically you have to give us the stuff for free. And, behind the stage, they're making licensing deals left and right. They're talking to everybody. So they know, in fact, that it might go that way. So they were trying to get this massive handout. It'd be like, giving me the West Coast of the United States because I said I need it for my work. And you forgetting to say, well, could you maybe pay something for that?
Social media is quite an interesting example of, in the tech space. Mark Zuckerberg had this phrase, move fast and break things. What could possibly go wrong?
That's how I start my book, in fact, is with that phrase. And a lot could go wrong with AI, right? So, we already saw a lot went wrong with social media. Like, it's been really terrible for teenage girls. I think lots of people are addicted. There's a wonderful piece called Twitter Poisoning, or that's in the title, by Jaron Lanier, where he uses the example of Elon Musk. And he says, if I had gone to Elon, I'm doing this from memory, so I might not get it exactly, but he said, I've known Elon Musk for a long time. And if I had gone to him in 2016 and said that you're going to spend, multiple hours a day on Twitter, and it's actually going to hurt your car business, maybe your rocket business a little bit. It's going to make people really hate you, and yet you're going to be compelled to do it a few hours a day. Musk would have looked at him and said, you're insane. Of course I wouldn't do that. I have work to do. But he got addicted, right? Twitter is addictive, and I speak as someone who's addicted to Twitter and would like to stop. It takes up a lot of people's time and emotion. There's some value in it too, where I wouldn't keep doing it. But so social media is addictive. It has probably increased loneliness. It's certainly increased political polarization. AI might do all that worse. So it might make people lonelier. So, one of the consequences, I think, of these chatbots is a lot of people are going to fall in love with those chatbots. It's already starting to happen. And they're going to lose or never develop, depending on their age, whatever social skills they had, because they spend most of the time with the chatbot. There was an old study showing that people who watch more television are less happy than people who watch less television. And it's partly about opportunity cost. If you watch television 5 hours a day, you actually enjoy it in the 5 hours. You pick shows you like and whatever. But at the end of the day, you haven't learned a skill, you haven't gotten a better job, you haven't made a new friend. Social media is like that. Well, AI is going to be like that even more so. On the polarization front, polarization in large part comes from misinformation and targeted misinformation. Well, AI is going to accelerate all of that. If it's even possible to believe, we're probably going to have an even more polarized society than we already have as a function of deep fakes and other kinds of misinformation or disinformation by deliberate design. There are lots of ways in which moving fast with AI is likely to break a lot of things.
Yeah, I mean, you said automated disinformation may destroy what's left of democracy. I mean, it sounded a little bit hyperbolic. I mean, how do you see that rolling out?
It's not, though, I think. I mean, I genuinely worry about that. So we are going to have elections, which is how do I say it, is the ultimate act of democracy is an election, especially if you have a representative democracy. You don't get to vote on individual things. You have referenda and stuff like that. But basically, we live in a representative democracy, and misinformation may undermine that. So, we may this year in October see deep fakes about one or the other candidates that actually materially changes the election. That really can undermine democracy. And we're going to see that more and more around the world. And parallel to that, and part of Russia's game plan has always been what they call the fire hose of, fire hose of misinformation or something like that. Fire hose of propaganda model. And the idea behind the fire hose model is not to push one lie, but to push so many lies that nobody knows what to believe anymore. And that is what's happening.
What was that Adam Curtis film talking about that? Was it hypernormalization?
I don't know the particular, but I mean, this is a well-known thing. I think it's called the Russian fire hose, a propaganda model. It's been something that Putin has cared about for a long time. And we are headed to what was always Putin's endgame, which is nobody will believe anything. So, just in terms of images are basically done. For 100 years, if you had a photograph of something, that was serious evidence that it was true, and people knew that. And as of, the last couple of months, people know that that's not anymore. Well, people don't know what to trust anymore. And authoritarians like that. They just go in and do what they want and say, you can't believe that other thing. Don't believe it. And I mean, look at the bald-faced lies that Putin tells all the time about the war in Ukraine, right? If we move to an environment where basically nothing can be trusted, as I think we are, that's really bad. One reaction that people have had to all of this as well, of course, we need to educate people about misinformation so they'll be more skeptical. And that's true. But in the limit, it's not so good, right? In the limit, if nobody trusts anything, democracy can't really function, right? I mean, the currency of democracy is information and informed decisions. And if you don't have information and can't make informed decisions, then you don't really even know what you're voting on, and then democracy dies.
It's ironic, isn't it, that when there's no knowledge grounding to reality, that we become like ChatGPT because we can't verify anything anymore. But it could go one of two ways. Dennett argued that it would tend towards acquiescence, or the other argument is that it would tend towards skepticism and rational thinking. Where do you think it'll go?
Might be some of both. I mean, I guess this remains to be seen, but I think a lot of people will feel defeatist and just give up. They kind of won't believe anything, but they'll kind of give up trying. I mean, I hope I'm wrong on that. I've been right about, I think, nearly all of my AI predictions. I hope I'm wrong about this political prediction that people will just sort of enter a despair and not really care about truth anymore. But I already see signs of that on Twitter every day.
I mean, people talk disparagingly about you, and the thing is, I mean, actually, DeepMind had a motto: "Solve intelligence and use that to solve everything else." And you admitted in your book that AI does have the potential to revolutionize healthcare and bring abundance to our lives. So, what is the game plan here? What are you trying to do?
We need to move past Gen AI, for one. And for two, we need better regulation. And there's some overlap between the two. So on the technical side, generative AI is just not a good way to do AI. It's fine for certain things like brainstorming, and it's fine for making images if it's properly licensed. But it is not fine for running power grids. Medical remains to be seen. It's not a reliable framework. It's been very hard to get people to understand that. I'm amazed that you still see things like a famous physicist the other day said, I had a conversation with ChatGPT and I couldn't believe how bad it was. I'm like, where have you been? We've been trying to explain to you that it doesn't actually understand what it's talking about. So that message has not been communicated very clearly, so people over rely on it. There's going to be weird economic effects, I think, when the bubble bursts. I don't think Gen AI has been good, and it's not on balance, I don't think, I mean, it's an interesting question. Has it been of net benefit or not? And I'm not so optimistic, because I think mostly Gen AI is a good tool for bad actors and some limited positive uses. And I don't think those positive uses maybe outweigh the negative uses, particularly if we get to this regime of disinformation where democracy is basically undermined. Like, I don't see any amount of productivity gains as justifying the end of democracy if we get there. So Gen AI, unfortunately, is a very good tool because it doesn't track truth and it doesn't understand factuality, but it mimics very well. It becomes a very good tool for bad actors, but a less good tool for good actors. And so I'm very concerned about that. And I think we need other approaches to AI. So, there's a lot we can still do and invent in medicine and technology. For example, we still don't really have a good way of handling Alzheimer's. And I think AI could be extremely helpful with that. Not generative AI, but some future form of AI that can read the medical literature, do modeling of proteins, integrate it all. There's an interesting new paper about AI scientists. If we had some future form of AI, we might actually build an AI scientist. Right now, it's just not going to work that well because they can't really reason about data. They can't plan. You had Subaru on your show. I'm sure he talked your ear off about how they can't plan. You can't really be a scientist if you can't plan. But eventually, we'll get to other forms of AI, and maybe that'll be great. I can't promise that it'll be great, but I could see ways in which it could be great. Then there's the governance side of the equation. We're basically letting the companies do whatever they want without regard to consequence, and that's just not good.
Yeah, the AI automated scientist paper is very good. They're coming to London. I'm going to interview them next month, so I'm very excited about that. But you said that AI is being rushed out the door, but if not now, when?
When should we have AI?
Yeah.
I mean, I think a lot of the stuff that we have now should actually be in the lab and not, commercially deployed at large scale. So I have no problem with people researching Gen AI, trying to find. I mean, all my issues are around deployment. So, for example, we know that Gen AI is being used to make healthcare decisions and job decisions and so forth. Let's focus on the job decisions. We know that employers are sticking their job applications in and saying, who should I hire? And we know that there is likely to be discrimination there, but we don't have public access to like how bad the problem even is, how much bias there is. But there are almost certainly bias against minority groups, for example, in using LLMs to make job decisions. And this is just not good. And I'm sure it's happening literally every day, at large scale now.
So I spoke to Yoshua about this last night, and he said freedom of speech is really important. We need to protect innovation. I don't want someone to say to me that I'm not allowed to use AI in this way. I mean, what would you say to that?
Oh, I would say that society has to balance values. And the United States Constitution and the laws around the laws of the land have made certain decisions that I would say are good. Like generally there's freedom of speech, but there's carve outs for certain kinds of things. And that we also, for example, protect against discrimination. So we have an Equal Employment Act. And you can't just like pick and choose and say, I'm going to keep the free speech and to hell with the Equal Employment Act. Like, I don't see the justification for that. And so you have to say, how am I going to balance this? So if I give you, carte blanche to use these tools that I know are just, are almost certainly discriminating against people, and really I should have access to the data, somebody should have access to the data, that's just not cool. You can't, I mean, I don't know how else to say it, but adults realize that different kinds of constraints can be in conflict, and you have to find some way of handling the conflict. And right now, the idea of complete free speech to build whatever you want, and free, whatever word is I'm looking for, free carte blanche to build whatever you want, is in tension with a bunch of other things, like laws that prevent discrimination in jobs, employment, etc., or any rational thing you might have about sort of the commercial production of misinformation, which is actually not very well protected in the United States, but is protected in some other places. You have to balance these kinds of things. And I think to say I'm only going to look at what I as a programmer get to do and not worry about the consequences of society, either the legal ones or the moral ones, that's just wrong. I mean, it's morally wrong.
For things like discrimination, do you think it would be covered by existing laws? I mean, for example, in banking, fraud models and credit models have very specific regulations around them already.
Some things are, some aren't. So, for example, it's just not clear how much the Equal Opportunity Commission can audit what's going on. So they work on a case-by-case basis. Somebody walks in and says, I think I've been discriminated against. Here's my evidence, and they take on the case. It's not clear they can do the auditing that's required. So that'd be one example where I don't think the existing laws cover it. Here's another one where it's still very ambiguous, which is defamation. So large language models have, for example, accused people of sexual harassment that they did not actually commit. We know that they didn't commit it, but it's not clear that the people who were defamed by this have any recourse whatsoever. Because the existing laws of defamation, for example, there's a bunch of complications here, it hasn't really been cashed out in court how it's all going to go, but typically there's some notion of intending malice. Well, you could argue that large language models don't have emotions, they don't have malice. They're not doing it on purpose. It's actually a kind of negligence that's making them do this. But are we going to say that you can make a system that's arbitrarily negligent to the point of really screwing up people's lives, perhaps, just because they work differently from people? Like, that doesn't seem to make sense to me. I would say the existing laws don't clearly handle what happens if some AI system completely negligently defames person. And it's completely negligent because there's no fact checking on top of these systems. So, my favorite example of hallucination is not particularly defamatory. One of these systems said I had a pet chicken named Henrietta. I don't think that really causes me any harm in the world, but there's also nothing I can do to stop it. And there are other cases like, certain law school professor was accused of sexual harassment, and there's probably nothing he can do about it.
I think you're absolutely right about automated decision making. On text generated by LLMs, at the moment, I can still smell it 100 miles upwind in a hurricane.
Well, you think you can, but all the studies that I know show people are not that good at it.
That's right. Just look at LinkedIn.
Well, there's tons of it out there. There's certain giveaways, like the word delve is way overrepresented in LLM speech, probably because the Kenyans who did the RLHF actually use the word more than we do over here, let's say in the States. But people have done experimental work, and I don't think there's any system that can detect LLMs more than 70% correct. So if you're talking about, for example, could we use these pieces of software that look for LLMs to, weed out student papers, let's say, 70% correct or 80% correct or whatever is just not good enough. I mean, imagine you're the student who wrote the good paper that is described as an LLM. You're going to be really, really upset if you're in that 1 in 5 who got screwed, and justly so. And so you can't, or you shouldn't be using software that's that bad at a task like that. I mean, it really has to be better. Nobody knows how to make a 99% accurate LLM detector.
Yes, that's very true. When I spoke with Luciano Floridi, he said that the problem with this information technology is that there's no friction whatsoever between it and the regulatory, the legal landscape. And open sourcing models is quite an interesting thing. So, do you think the horse is bolted?
I think there's multiple horses. One of them has, and some of them haven't. So the horse of LLMs that can be used for misinformation totally left the barn. You know, Meta's latest model is probably good enough to make whatever misinformation anybody wants sound plausible. And, now the weights are out there, and there's no way to put that back. I mean, short of like a nuclear war that like sets the entire civilization back, short of really crazy kinds of things happening, that's never going away. So that horse has definitely left the barn. There's probably going to be another 20 important advances in AI. I'm making up the number 5, 10, 20, 100. And we don't necessarily have to handle them all the same way. So the open source question is extremely complicated, right? There's a lot of reason to want to accelerate progress towards AI, and open sourcing things clearly accelerates them. But there's also a lot of worries about bad actors and what they're going to do. And, I find it to be pretty difficult. I will refer your readers to a paper that I wrote in Substack that was about an OpenAI paper that purported to show that LLMs don't make bioweapon manufacturer worse. And if you actually look at their data, they did their statistics wrong. And I see that paper cited sometimes, and it worries me. So it's not all clear yet, but it is possible that LLMs will, for example, be used as tutors to teach people to make bioweapons that couldn't. And, even a single incident like that could kill tens of thousands of people in a subway or something like that. So there's some definite potential downside risks. What upsets me is that it's a really complicated decision that should have been made by a lot of very bright, thoughtful people trying to work through their differences. And instead, basically, Meta made that decision by themselves. And now, if there are negative consequences, the whole world has to absorb it. In fact, a favorite phrase of mine lately, I didn't coin it, I wish I had, is to socialize the consequences and privatize the profits. And so, Meta gets all the gain of open sourcing their stuff. Their software gets fixed by lots of people. They get a lot of credit. They use that primarily to recruit people that they weren't otherwise getting because they had taken some reputational hits. It's all plus for them. Now, if it turns out that a bunch of people die because the software was abused, then that's something society absorbed. Meta's not going to make anybody whole. They're not going to bring back, your sibling that was killed in a nerve gas accident. This is not good.
So we have folks like Elon Musk, and he's really focused on the X risk stuff. We've got people like Jan LeCun, for example, who I think, in your opinion, has adopted many of the talking points that you've been making for many years, but quite dismissive about things like misinformation, for example. I mean, what do you think about that?
Well, I mean, there's a lot of different players. A lot of different people have different incentives. Some people, I think, are speaking from the heart. Some people are speaking from the pocketbook. Like, I don't know if Jan LeCun really thinks that there's no possible risk from AI. I mean, he's actually attacked Elon Musk for spreading misinformation. He must know these tools could be used to generate misinformation. There's already reports that they've been used in the wild, and he says they can't be used for misinformation, but he also works for Meta. And I don't know what he really believes in and what's an economic incentive for him. Elon Musk is, a riddle in many ways. Lately, he seems to be driven in some ways more by attention than in principle. I was talking to him for a little bit, and I think that he's genuinely concerned about AI risk, but he's also, building frontier models just like everybody else. And the last communication I had with him, which he didn't respond to, I emailed him when he came out strongly for Trump. And I said that if you really care about AI risk, supporting Trump might not be the wisest move here. And he didn't respond, and he is supporting Trump. And I don't see how to square all of the different things that Elon Musk has said. So I really do think that he cares about AI risk, that he's not putting that on, but he's doing a lot of things that may actually exacerbate AI risk. And so, he's not integrating over all of his beliefs, in my opinion. And then there are other people. I think Demis Hassabis is maybe one of the straighter players. I think that he really is worried about AI risk, and behind the scenes, he's trying to do something about it. You have Anthropic, I think, really started caring, but now they have visions of dollar signs dancing in their heads, and I think they care less than they did before. OpenAI, I'm not sure they ever really did. I really lost faith in those people, but they certainly talked more about AI risk in older times, and clearly they focused primarily on commercialization, and so they've shifted. So you have lots of different players. There's a cartoon that I showed in my talk and is in my upcoming book by Cal from The Economist, where you have all these companies saying like AI, or I think it's countries rather than companies in the cartoon, saying, but it would apply just as well. The companies saying, we're terrified of the catastrophic risk that AI might destroy us all. And then, that's at the top of the cartoon. And then all the same players are saying, and we're desperate to get there first. Right. So there's this tension throughout the industry that I think comes out most clearly with Dario Amodei, who's the CEO of Anthropic, who has been saying that he thinks we might get to AGI in 3 years, which I think is ridiculous. We haven't actually talked about that. But he seems to genuinely believe that. Maybe it's just hype to raise his valuation, but he seems to genuinely believe that. He thinks that his so-called P-doom is very high, maybe like, I don't know if he gave a number, but let's say 50%. Like he thinks this stuff might really kill us. And he used to say, so we're not going to work on frontier models. Now he's working on frontier models just like everybody else is. And so, like, I don't know how those ideas simultaneously can exist in one person's head. Like, if you really thought that the technology you were building had a, 40, 50, 60% chance of annihilating the species, which I actually think the number is lower. But if you really thought there was a 40, 50, 60% chance that the thing you were building might annihilate the species, or let's say just decimate it, kill, 10% of it, like, how could you morally keep working on that? But that seems to be where his head is at.
But you think they believe it genuinely?
I mean, so that raises the question of like, is it all hype? Does he actually believe it? How does he square? Like, I can't literally get inside these people's heads. I can just say what I see from the outside, reading, what they're doing. I would say I think different people have different beliefs and about why they're doing it and what they think the risk is. There are clearly some people whose P-doom over the next 10 years really is like 50%. They're not putting it on. My P-doom is much lower than that. I don't think we're going to annihilate the species. My P-democracy gets really seriously impaired is very high. I think that that's a likely outcome of LLMs. The idea that we're going to eliminate this human species seems to me not absurd, but very unlikely. So it's not zero. I'm glad some people in the world are thinking about it and how to defend about it. And I think more generally that alignment is very important, even if you don't think about literal extinction. So literal extinction, it just seems weird to me, right? We're a very physically diverse species, we're very geographically diverse species. We're somewhat physically diverse with different genes. So you think about COVID was really bad, right? I mean, it's a horrible, horrible disease, but it still only killed 1% of the population, not 50 or 80 or something like that. So even if a system tried to design COVID, it wouldn't necessarily stop all humans in all places. Like, I just think that that's unlikely. On the other hand, I do think that there's a real risk of some kind of catastrophe. For example, somebody might try to short the stock market. And I hope this isn't one of those Marcus predictions that turns out to be true. There's been a lot of them. Somebody might try to short the stock market by using LLMs to cause as much harm as possible in as short an interval. Short it just before that, try to make a bunch of money. Like, that might actually happen. And, a lot of people could die because people set airplanes to crash into each other or whatever. So there are real risks like that. There are risks that misinformation could lead to even a nuclear war, right? So, we blame the Russians for doing something they didn't actually do. They get mad at us. It's back and forth. And then we get into it. There are a lot of scenarios like that. And I think the probability that something bad will happen as a consequence of all of this, like seriously bad, is actually fairly high.
Yeah, I mean, I interviewed Sayesh Kapoor, one half of AI Snake Oil the other day. He had a great piece out about these subjective probabilities that are used for PDOM, and I agree. I'm not a fan of casting it as a probability. But
Yeah, no,
yeah,
I wrote a piece also in Substack some months
yeah.
ago about PDOM, and like I also think that most of the numbers are made up and post hoc justified and so forth.
Yes, indeed. But one interesting thing though is that in a way you're strange bedfellows with some of the AI risk folks because it's still safetyism in a sense. I mean, how do you feel about that?
Um, well, I mean, I think that goes to the part that I think really is important, even though I disagree about the strong extinction narratives. The part that I think is important is we need to have two things. We need to have a global agreement about how we're going to handle AI as it gets more dangerous, um, sharing information and things like that. And we need technical means for alignment. And that will only get more important as AI is A, empowered more, which is to say, given more responsibility in the world, and B, as it actually gets more proficient in doing the things that it is asked to do. Because there will be more opportunities for bad actors to do bad things. And you want your system to actually be able to calculate, is this going to have an adverse effect on a large part of humanity? Then I shouldn't follow this instruction. Like you actually, the X-riskers aren't wrong to want something like that.
Well, no, that's the thing. It's very reasonable, and they have kind of concentric circles of, on the inner circle, they're talking about being paper clipped, and then they increasingly talk about more and more plausible risks. And the reason I made that comment is I made a video commenting on your Senate discussion with Sam Altman, and you're famous for being very skeptical about the capabilities of neural networks. And at one point in the meeting, you were talking about the possibility of them becoming self-aware, and that just seemed
I mean,
incredible.
I don't know what the odds are on that. I think I can't remember what I said, but my general comment on that is I don't think we should cross that bridge. I don't. I mean, it's one thing for a system to have a model of like where objects are and so forth, but there's a certain level of like agency and consciousness that a bunch of people, including at this conference that we were just at, would like to see happen, and I do not want to see happen. I think it just opens another. Barrel of worms. It's not like I think that's imminent. Like, and you have to understand that most of my skepticism about AI is skepticism about what we can do right now and overclaiming and so forth about current capabilities. I think AGI is possible.
Mm.
I don't expect to see it next week. And I offered Elon Musk $1 million bet when he said that he thought it would happen by 2025. And I would still love if he would make that bet because it's easy money and why not? Even if it goes to charity, I'd be happy to make the bet. Elon, it's still there. And I have a friend who will raise it to 10 million if you're in. I don't think AGI is close. But I don't see any principled reason why it's impossible. I've never seen a good argument for that. The arguments I've seen about that are all kind of like mysticism or something like that.
But I think people will be interested to hear you say that because people interpret your skepticism as you being a kind of Luddite in a way, and that's not really the case at all,
It's
is it?
totally wrong. And I mean, I've publicly said this a bunch of times that it's totally wrong. I think a particularly good place was when I was on Ezra Klein's podcast. And he said, a lot of people might think you hate AI, but you built AI companies and you've been writing about it for years. You've been interested in the kid. And I said, I'm glad you asked that because I do actually love AI. Like I wouldn't be doing this if I didn't think there was a good outcome that was possible. If I thought it was hopeless, I would, just stop. I would stop writing about AI if I thought it was hopeless. Hopeless, I should say, on a technical side or on a kind of governance side. But I do think there's a chance we can do this right. And that's why I sit here on whatever, Twitter every day trying to get us to a better place in AI because I think it is possible and it is of value. Not everybody will know, but I'm a high school dropout. And the way that I pulled that off is, and I went straight to college. And the way that I managed that is I wrote an AI program that translated a semester's worth of Latin into English. So, I mean, I was coding AI as an independent project when I was 15 in the programming language Logo, which is a little bit like Lisp, which I couldn't get my hands on. I have, 8 and breathed AI for a long time because I think it's interesting, because of the way I think it reflects on human cognition, because of the value I think that it could bring to science and technology. I want AI to succeed. It's just that I think we've gone down this terrible rabbit hole where the people who are running AI now are not researchers. They're marketing type people, and not really that interested in the morality of how this stuff is being used, which I think was not always true. So I think that the culture and politics have changed. And I think technically we have gone from a healthy scientific environment where a lot of people were presenting a lot of different models and comparing them, thinking about different ideas, to one in which everybody has zeroed in on a technology that I think is fundamentally flawed, which is the large language model. It's not that I think there's no value to it, but I don't think it will get us to AGI. I don't think it will get us to the medical discoveries that we might make and so forth. I think it's the wrong avenue, and it's also sucking down an enormous amount of resources. So, $100 billion went into driverless cars, basically mostly on similar technology. I don't know the exact dollars. And 50 billion plus has gone in just to chips on large language models. And anybody who's a grad student works on large language models because that's where the money is. And so it's not an intellectually healthy environment. And it's absolute absurdity that you have 7 companies or something like that, all basically building knockoffs of GPT-4. That's tens of billions of dollars that could go towards developing better approaches to AI. People the people that hate me the most are the EACC people, what do they call them? Effective accelerationists. Yeah. And they don't understand I'm actually on their side in a certain way, but they really don't get it. I've tried to explain this. And the way in which I'm on their side is I'd like to see AI move along faster. And what they can't separate is AI as we do it now, which I think is really not what we want to do, from AI as we should do it. I think that a good EACC person should say, our end game here is not to make LLMs, ubiquitous. Our end game is to make AI that would help people and make society better. And ask the question, is this the right way to get there? And the answer is pretty clearly, or, I'll say highly likely, no. And so EACC people should be my biggest fans. They should be like, that Marcus is sitting there every day, absorbing arrows, trying to figure out how to bring us to an AI faster that would be better. How could they not like that?
Well, that's a beautiful point, because I hosted a debate with Beth Jezos, the head of the EAC, and Connor Leahy. And Beth is creating this company to build physics-inspired intelligence called Extropic. And Connor's argument was, you're basically submitting to the void god of entropy in terms of morality. So, what if we just built this kind of physical simulation of the world and we just trusted it to be moral? So presumably you wouldn't be a fan of that.
I mean, I'd have to know the details, and I watched a little of the video and wasn't, wildly impressed, but and so didn't pursue it more. But I would say that building a simulation is not building a moral reasoner. Those are not the same things. And so, for example, there are some scientists who understand physical laws pretty well, and some of them are ethical and some of them aren't. It's just a different thing. You want some philosophers involved in the ethical side and so forth, the ethicists. They're just different things. If you have a perfectly faithful simulator of the world, which I think, gets into Laplace's demon and is not a realistic thing in the actual world with finite resource. But if you had it, it still wouldn't give you ethical decisions. We still have legal frameworks, ethical frameworks, and so forth, independent of our knowledge of how the world operates. Now, I think there's a small connection, which is one of the things an ethical AI system ought to do is to evaluate the consequences of its actions. And so the better the simulation you have, not just of physics, but of sociology, and there's multiple layers of understanding that we should have of the world, levels of understanding. But if you could understand economics and psychology and so forth, and you could simulate all of these really well, probably better than is actually realistic. But if you could do that, even decently well, in the context of an ethical system that is trying to avoid harm to humans, then great. Think of Asimov's laws. The first do no harm. Think about that from a technical perspective. You have to actually calculate, would this action cause harm? And the better the simulator you have, the better you can do that, but you can only, like, you have to know to do that, right? If you have the ethical principle of do no harm, and of course Asimov's stories were about how you get into various tricky, edge cases or whatever, but if you start with a system that tries to anticipate the consequences of its actions, then a simulator is very helpful. If you don't start with that premise and you just have a simulator, like, so what? Like, and you can use the simulator to, do a bunch of things, but like, you have to have the ethical framework in order to leverage that.
Well, exactly. But for you though, if we need to have a moral calculus, presumably you think there are moral facts about the world. Where do they come from?
I mean, they're moral axioms. They're not facts. Like, you have to take a position there. There's no moral set of facts independent of humans in the world, right? And that makes a lot of people run away screaming. They're like, we're never going to agree. But the fact is, there's a lot of stuff we actually do agree on. We don't talk about the stuff that we agree. But if you took a survey of, 100 people on the street and said, is murder okay? 98 of them would say no. You could also say, what if it's in self-defense? And a lot of them would say, okay, maybe. And, tell me about the circumstances and so forth. But, there's a lot of stuff we actually agree on. There's some stuff we don't. So when is the beginning of life? Like, people disagree about that, and it's not clear there's a fact of the matter and so forth. But there are some moral principles, a lot of moral principles that most people actually agree. We mostly agree, don't steal stuff, don't kill people. The 10 Commandments wouldn't even be such a terrible start, but we don't even know how to do that, right? So, like, don't lie is, maybe a principle that people are less agreed on, but to a first approximation, they agree on it. But you can't tell an LLM don't lie. It does not compute in an LLM, right? They literally don't understand that. So yes, there are disagreements, there are cultural differences and so forth. And people want to play a slippery slope argument and say, don't even try to build ethical AI. But that's actually taking a stand too, right? It's, in a way, it's taking an extreme libertarian view of anything goes. And at the most extreme, I think even libertarians aren't actually that comfortable with that. There's a lot of, libertarians are not, in fact, all saying, well, we should just legalize murder. Like, they're just not saying that. And if they did, we wouldn't take them seriously.
I think there was an example you gave in your book, though, of a huge cultural difference in China. My mind's slipping on it. But presumably you do think that AI legislation should be enacted quite differently in different cultures.
Well, the thing that I object to most in Chinese AI regulation, which is actually much stronger than U.S. AI regulation, is a insistence that everything be consistent with the party line. And I would not like to see that in the United States. I don't like seeing it in China. It's sort of, it's not as much my business, or maybe none of my business, if they do that in China. I certainly don't want anything like that in the United States ever. It's not legal to operate a chatbot if it doesn't, conform to what the state believes is, So it's one thing to say chatbots shouldn't promote, conspiracy theories that are clearly false or whatever. Like, I can imagine something in that direction, but becoming an instrument of the ruling party, no, I don't think that's just. I don't think anybody on the planet should do it. I can't stop China from doing it, but I think it's wrong that China is doing it.
So, Gary, almost exactly 4 years ago, we invited you onto MLST. We had early access to GPT-4. It was actually Connor who gave us access for a secret API. He wasn't supposed to, and we invited you on and Waleed Sabah, and we spoke about it.
4 or 3? It was probably GPT-3.
It was GPT-3 4 years ago. I think it was about November 2020. And the amazing thing, first of all, is the consistency of your position. And even now, the video's got hundreds of thousands of views. Every day, people are commenting on it, and they're saying it's aged like fine wine, but in quite a polarized way.
What I said was it.
Yes. Isn't that incredible?
I've not been able to put people in the headspace that I am. To me, none of what's happened is surprising. I figured out basically how this stuff works in 1998, and it hasn't really changed. There's statistical approximators that don't have world models. And once you understand that, the likely flaws like hallucinations just jump out. And so, I was writing about hallucinations in my 2001 book, The Algebraic Mind. And it's not like there's ever been a principled solution to hallucinations or the stupid errors of reasoning. And it's not even reasoning, it's approximation. The stupid errors that come from approximation. Nothing has ever been principled. Nobody has come up with a principled technology to solve them. And so, of course, those errors still happen. Like, to me, it's just obvious that all this is going to happen. And what I always get is, well, we'll just add more data and it'll solve it. And I say, it's not going to solve it because it's not a principled solution. Come back to me with a principled solution. Explain to me, for example, in the passage in which I anticipated hallucinations in my 2001 book, I gave the example of my Aunt Esther, who sadly passed away last summer. And I said, suppose that she wins the lottery. And what's going to happen to a system that doesn't have a distinct record system for individuals as opposed to kinds? What you're really learning about in these systems are properties of kinds, not individuals. You don't have an individual level predicate. And I noticed that Subaru has started saying some fairly similar things recently. So I made this argument back in 2001. I said, there's this principal problem. If the system is told my Aunt Esther wins the lottery, it's going to think that other women who live in Massachusetts or who work for Harvard or, that share some properties with her also, are a little bit more likely to have won the lottery. But that's not how the lottery works, right? Other people that are in your, pigeonhole advertising category didn't also win the lottery. And the system doesn't understand that this individual property inheres in this individual because it doesn't have a mental representation like a database of particular individuals. And so it was plain as day to me. I think I did some modeling on one of the models of the time by Ronald Hart and Todd, if I remember correctly, showing that kind of error would happen. And then you want to come to me and say more data is going to solve that problem. Well, I did this work back in 1998. I know that's not going to solve the problem. You need an actual solution to that problem. More data is just hand waving. So, of course, my predictions, aged like fine wine. The only thing that would make those predictions break is if somebody actually came up with a principled solution and said, here's how we're going to handle compositionality in this architecture, or here's how we're going to handle distinctions between individuals and kinds, or structured representations, or operations over variables. And instead, people are just hoping that, like, by magic, by having enough data, they'll go away. And they get confused because any individual puzzle that I put out there may get solved. I mean, as we saw with the horse rides astronaut, even sometimes they're out in the literature and they still don't get solved. But in general, any given puzzle can be, because these systems are in part big memorization machines. That's not all they are. It's a bit of an oversimplification, but you can think of them roughly as lookup tables. And so you can store, multiplication table is a lookup table. So you can store anything you want in a lookup table and fool yourself into thinking your system has it. So you could take a young child who hasn't really learned what multiplication is, give them a multiplication table, and they could tell you what 6 times 7 is because they memorize the table. That doesn't mean that they understand multiplication at an abstract level. And so what happens time and time again, and I've been watching this for 30 years, and it kind of breaks my heart to keep seeing it, is that people will see a single correct answer and assume that the system has the correct underlying abstraction because they don't understand how to think about data and errors. Like, that's what I really learned from Steve Pinker when he was my mentor, was how to think about data and human errors and algorithms and what the mean. But people don't have training in that. So they just say, well, if there's some generalization, then the system is done. And in fact, the point of my 1998 work, which I still think is my best work, was to show that there's two different kinds of generalization. There's generalization that's kind of nearby to the examples you've seen, and there's further generalization that's further away. Nowadays, we call that distribution shift. I basically was writing about distribution shift and how neural networks are or are not good models of human minds in 1998. So once you understand there's different kinds of generalization, which may be 2% of the population or 2% of the people in machine. No, I guess that's not fair. But 2% of the population understands, and a growing fraction of machine learning understands. Once you see that, you realize that there are serious problems. But there are a lot of people who just don't understand that basic distinction, and they imagine a level of generalization that is not there. It's kind of over anthropomorphizing the system, etc. And once you're down that path, then you believe, okay, more data will solve this or whatever. Once you're down the correct path, it's just obvious. Once you really understand what these systems are doing, it's just obvious that they're not miracle workers, that they're not going to solve these problems. These core problems are not going to go away. I looked at Sora for 2 seconds and I said, I'll bet you that that's going to have problems tracking objects over time, because there is no representation here of the individual objects. It's at a pixel level. And sure enough, it had tons of problems. Like, I look at these systems and I can usually take them apart in a few minutes, because I can kind of see how they're working and what they're lacking and that comes from a perspective of being a computer programmer since I was 8 years old, and B, a cognitive scientist since I was 13 years old. And so I see it and I know.
It's annoying how dismissive people are. I mean, when our Chomsky video, it's had nearly 1 million views. It was the most amazing experience of my life. Read the YouTube comments. And I don't know whether people just don't understand it. It's so annoying watching people just write you off.
Yeah,
Frankly.
people write Chomsky off all the time. And they'll do it like based on his politics. Like, I disagree with his politics, so he must be wrong about linguistics. That doesn't actually follow, right? I mean, I actually disagree with his politics, disagree with some of his linguistics. But when he says that large language models haven't taught us much about human language, he's right. It's like, we don't have a better theory of how humans use language from large language models, because large language models, as it happens, depend on having like the entire internet as a corpus. And it's obvious to anybody who's had a 3-year-old child that, they listen for a couple of years, not to the entire internet, and then they basically understand it.
I know, but there are trolls everywhere. I mean, many of these people don't probably know that you sold an AI company with Kenneth Stanley called Geometric Intelligence.
Ken Stanley, Zubin Garamani,
Yeah.
Doug Bemis, Jeff Kloon.
Yeah.
We were all part of that. I was the first person to kind of launch the company. I brought in Zubin, then eventually we brought in Ken, eventually we brought in Jeff. Yeah, I mean, most people don't know that. I mean, it's there in Wikipedia. It's there to be found. Every now and then I'll push back on the trolls who attack me and say, well, do you have papers in Science and Nature? Did you sell a company to Uber, machine learning company? Of course, they did. Like, I don't know how to respond to that. Like, people either put in the time to actually understand who I am, or they don't want to. I mean, they really don't want to. They want to demonize me, as with Chomsky. Surveillance capitalism is basically that the companies make their money by invading your privacy and selling information about you to, all sorts of people, either directly or indirectly. And I have to say that something that just like turned my stomach the other day was OpenAI bought a webcam company. So I already knew that they were trying to like access all your documents. They have a deal with Microsoft that was going to do this thing, taking screenshots every 5 seconds. I think the public maybe shot that down. Initially, they had a database there in plain text. So even if Microsoft wasn't directly going to do something bad with it, like any bad actor with any, chops would have been able to take all this stuff. So already you had this situation where they're clearly trying to get everything they possibly can about you, and to commercialize it, probably to sell ads. And then they bought a webcam company. I just they're having a lot of trouble actually making money at OpenAI. Like, they lost, operating loss, cost relative to revenue last year, $5 billion. A lot of companies tried their software and are not that excited about it, having tried it out. Copilot, which is run on their platform, a lot of people aren't that happy with it. Microsoft is like trying to rush people to use the product. Everybody tried it. It's not like there was a lack of marketing, but it's not that reliable. So OpenAI is faced with a problem. How are we going to make money off of this stuff? And it's not cheap, right? I mean, they've probably spent $10 billion on data and chips, and they're going to spend another 10 or whatever. I mean, GPT-4, who knows how expensive. They need to make money, or they will either go out of business, or Microsoft will take a bigger chunk of them. And it's not clear that VCs are going to want to up their valuation to $200 billion, given the kind of picture of revenue that is emerging. And so if I were Sam Altman and I had a different kind of morality than I think I do, first thing I would think about is surveillance, right? People are giving them all this data on a silver platter. Now you got a camera too. Like, that's the natural direction for the company to go, despite their name, quote, OpenAI, right? I mean, it's a really sinister thing for them to do, to become Big Brother. And did I mention they're still a nonprofit, which is insane? So we may very well wind up with the world's largest surveillance company as a wholly owned subsidiary of a place that calls themselves OpenAI that's nonprofit. Like, that is, I think, almost a default outcome right now. And that's, to me, upsetting.
What about the NSA guy they employed?
Well, that's clearly part of the same picture.
I mean, if I were them, I would be building language models on, you know, the government capture or the surveillance data. I'd be building a language model on that.
I'm sure the government is interested in doing that. And I think, they hired Paul Nakasone, who worked at the NSA. Clearly, well, I won't say clearly, but it would seem plausible that they hired Nakasone to try to get those government contracts. Like that would seem to be the play that they have.
Yeah, because other than the government, OpenAI is interesting because they go direct to consumer. The rest of the LLM ecosystem are developing, enterprise models. What do you think about that?
I actually don't see the winning strategy for anybody but NVIDIA right now. So NVIDIA is selling shovels in the gold rush. People want to buy the shovels. It's not their fault that people want to buy the shovels. They've been hyping things a little bit, but in general, people want to buy the shovels and they know how to make the shovels. They spent a lot of time. They're a very well-run company thinking about how to make the best possible shovels on the planet. And they really have that. And they're selling them. They're making a lot of money. Everybody else, I think, is struggling. Like Midjourney is making a profit, but there's going to be massive lawsuits, I think, against them, or else they're going to have to pay massive licensing. So at the end of the day, I don't know if Midjourney is going to make a profit. And most of the other companies, they have modest revenue. They're valued at like 200 times earnings and that kind of stuff. Not even 200 times net profit, just 200 times revenue. Like, these kind of crazy numbers. I don't think anybody has a strategy yet. Maybe in like a small sector, but I don't think anybody has the strategy yet to make, multiple billions of dollars profit year in and year out with this stuff. I think that's still a dream. I don't think anybody has a clear way yet of doing that on the business to business side or on the business to consumer side. I won't say absolutely nobody will get there, but there's a really serious problem for all of them, like deadly possibly problem, which is that Meta is now giving away for free essentially the same product as everybody else is making. So there are ways you can deal with that. You can have better customer service. You can, have a particular training set. So like, it's not absolutely knocked down. It's all over. Folks go home. Like there's still a chance, but that is a pretty serious problem. And, whatever you're doing, you got a competitor now who's going to do it on Meta's platform. So you're doing it with your own data set. Well, someone else is going to fine tune on Meta's platform. You're not going to pay for OpenAI anymore.
Is it a bubble? And is it going to burst?
So I'll say yes and no. So I think that the economics don't work. I wrote a piece last year called, "Is Generative AI Going to Be a Dud?" It was almost exactly a year ago to the day. I think that was prescient, and I think that it's becoming clear to all that the economics don't really make sense. I think a lot of investors are going to lose a lot of money. A lot of LPs, like pension funds that put in money to the investors, are going to lose money. I think enthusiasm is going to be lost. I think that the tools will remain. Meta is going to keep giving them away free, and people will still find some uses. But I think like a year from now, things are going to look different. Many people who like move from crypto to AI are going to move to something else because they're going to say, well, I don't see how to make money out of this. It may be that investment dollars become much scarcer. LLMs will continue to exist, but eventually people will try to find other solutions. I think neurosymbolic AI is maybe finally going to have its day. The recent results from DeepMind with alpha proof and alpha geometry were impressive. It's a moment where I think there might be a shift. So generative AI, I think, will never be as popular again as it was in 2023. The tools will always be there, but it'll be more like, yeah, use it for brainstorming. And, it won't be like, this is the messiah. This is like the greatest thing ever. Like people were saying like AI is, going to be bigger than fire and electricity and whatever. And the truth is most people would not take generative AI over their cell phones. Like everybody, if you take away somebody's cell phone, they're going to be pretty upset. A lot of people could actually live without generative AI. They played with it. It was fun. But if you said, look, I'm going to charge you $50 a month for it, most people would say, yeah, I don't really need it. Most companies have tried it out and they're like, yeah, we can find something, but people could live without it. And the hype last year was that it was this indispensable thing that was going to transform our entire world. AGI, if it comes, might be like that, right? I mean, if you really had a system that can understand the cognitive requirements and the physical requirements of any human job that's going to completely change our world. And I think that that will happen, maybe in my lifetime, maybe not. I think it will happen someday. But generative AI was not that. And it was never going to be that, as I told you, whatever it was 3 years ago. That reality has settled in, and it's just not going to be treated in the same way. Plus, you have the fact that Sam Altman's star has fallen somewhat. A lot of this was like his personal charisma. But a lot of people are skeptical of Sam at this point, and I think with good reason. And so you had this kind of rock star, and you had this, constant hype, like every day in every newspaper. And in 2025, let's say, people still use generative AI. They'll still be in the news sometimes. OpenAI will still be in business, but people will think the $86 billion or whatever it was valuation was probably too high. They can be like, how are they going to make money when Meta's giving this away for free? It'll still be there, but it's not going to be this, it's going to be like pet rocks. You can still buy a pet rock, I think, in a toy store. Like, pet rocks were, most of your listeners won't even know what I'm talking about, but at one point before I was born, like everybody was buying a rock and calling it their pet. And it was this crazy thing. Or Tamagotchis and you have these things that become fads that completely take over the world for a little while and then they disappear. A point that I've often made is that people over extrapolate. They think there's an exponential after they see a few data points. And there are different ways you can make fun of it. One of them I call the disco illusion. And this is somebody else's cartoon. Maybe we can put it up. And it's like sales of disco albums in like 1974 and 1976. And someone's like extrapolating, I forget exactly how the cartoon goes, that like in 1978, every record that is sold will be disco and forevermore. And we all know it didn't work out that way. Disco had its moment, and then, synthesizer music and punk and all kinds of other things took over. People got tired. It was fun for a while. ChatGPT is going to look a little like that. It's like, you can still buy disco albums, and I still like the soundtrack to Saturday Night Fever, and I listen to it sometimes. Like, it still has, a role in my life. It didn't completely disappear. I feel nostalgic about it, but I don't spend 24 hours a day listening to disco anymore. And people are not going to spend as much time with the chatbots, and it's just not going to be the center of our lives the way it has been really since November of 2022 when it came out.
Meta's interesting though, because they're building this metaverse and virtual reality and stuff like that. So ironically, they do have some potential use cases for the technology. But as some business leaders have said to me,
well, but I think then you can come back to the rest of your question. I think a lot of people imagine you could populate a metaverse world with large language model characters. And I think that that's going to get tired fast because those characters aren't really going to understand the world. And so it'll work for a little while, having non-player characters made by chatbots. But eventually, like, things are not going to make sense and it's going to break the illusion. The only way metaverse is going to work is if the illusion is so potent and it's so much fun to play with. And the more that, like, you have these weird experiences. Like today I had Grok. I asked it to make 11 eggs without an egg carton. Instead, it made 15 with an egg carton. And we have enough experiences and you're like, yeah.
I know, I was surprised by that. But wouldn't it be interesting? I mean, it might be therapy, it might be virtual partners, it might be gaming. Could there be an application, a killer application that does change it?
It changes metaverse?
Well, that makes generative AI, economical.
I mean, I think the killer app is going to be surveillance. I think that's selling everybody's personal information is historically been a profitable business, and I think that's where they're going to land. But I don't know.
Professor Gary Marcus, thank you so much for joining us today. It's been a pleasure.
I love our conversations.